Good morning, geometry class. Good Wednesday morning to you. Hope you guys are ready to learn some math today. I mentioned to you earlier this week that I will give you a lot of notes today, pretty much the entire class period, but no homework tonight. And I will give you homework tomorrow, but no notes tomorrow. So grab your notebooks. Let's get ready to take some notes for a long time. I hope you're staying up on your homework. Just because I'm not there does not mean you don't have to do your homework, and I'm really worried about some of you guys. So please make sure you're doing your homework. Some quick announcements. There will be a quiz on Friday. It will be a big quiz. There'll be nothing else on Friday. No notes, no lesson, no homework for over the weekend. There will be a quiz on Friday. You do owe me homework from last night, so would you please get that out while I'm talking and turn that in? You do owe me homework from last night. Now, any other incompletes that are not turned in by this Friday will become zeros, and you will not be allowed to make those up. Or at least all incompletes except those from Chapter 7. If you're behind on Chapter 7, and you really shouldn't be, and that's not a wise thing to do, but if you are behind in there, I will give you until next Friday. But all other incompletes must be turned in by this Friday, or they will turn to zeros, and you will not be allowed to make them up. If you're sick Friday, okay, something happened here in the video. I'm not sure if you guys heard that or saw that. Let's go like this, and there we go. Keep moving. Okay. Anyways, if you're not there Friday, then somehow you got to get them to me. Call me, email me. We'll work it out. So, all right. I think that's basically it on the announcements. And I want you to kind of sit back and just watch for a couple minutes. I do want you to take some notes. But right now I want to start the class period off going over a quick review over the past couple days. And just sit back, relax, watch the video, and I will let you know when I want you to start taking notes, okay? All right. First of all, I want to review something that we learned way back at the start of Chapter 7. And what we learned was this. We learned that similar polygons always have congruent angles, and they always have proportional sides. That's the definition of similar polygons. So here's a picture of that here for you. And again, you're welcome to take notes, but you don't need to. We're just taking a second and reviewing some basic important principles we've learned so far in Chapter 7. So here we go. Here is one polygon right here, and here's another polygon right here. And these two polygons are similar. So first of all, they should have congruent angles, and they do. 100 degrees, 100 degrees, 110, 110, 85, 85, 65, 65. So whenever you have similar polygons, you will have congruent angles. Now you should also have proportional sides. So let's take a look and see if we do. It looks like we do. I put 4 over 8 right here. I put 2 over 4 right here. I put 5 over 10 right here, and I put 5 over 10 right here. Now remember, if these sides are truly proportional, then that means when you reduce each of these fractions, you'll get the same fraction out, and we do. 1/2, 1/2, 1/2, 1/2. So I just wanted to quickly review the definition of similar polygons. They have congruent angles, and they have proportional sides. Okay? All right, let's continue on with the review. You're welcome to take notes, but you do not need to. We're just reviewing. We also have learned 3 quick ways to test to see if triangles are similar. Okay? And so let's quickly look at those 3 different ways. First of all, we have learned one way is the angle-angle similarity postulate. Okay? And what that states is, if I have one angle in one triangle congruent to an angle over here in another triangle, and then another angle congruent to another angle, in other words, 2 angles here congruent to 2 angles here, I can immediately stop and know for sure that these 2 triangles are similar. Now, do I know for sure that they're congruent? No, I don't. They might be, but I don't know for sure. But I do know they're similar for sure. Another way that we learned to quickly test to see if triangles are similar was the side-side-side similarity theorem. And what we learned is if I took one side here 6 and put it with its corresponding side 10 equals, and then put 9 over its corresponding side, which would be 15, and then I put 12 over 20, if I reduce all of these fractions, I would get 3/5, 3/5, And let's see, 4 goes into this 3/5. All right. If I reduce all of my ratios and I come up with 3 congruent fractions, just with the sides, then I know for sure that these two triangles are similar. So if the sides of one triangle are proportional to the sides of another triangle, then I know for sure the triangles are similar. And the third way we learn to quickly test to see if triangles are similar is the side angle side similarity theorem. And we said, okay, I've got a side angle side of one triangle and a side angle side of another triangle. First of all, I must have congruent angles, and I have that right there, and then the sides must be proportional. So 2 would go over its corresponding side 4, and 3 would go over its corresponding side 6, and if you reduce those two fractions, you would get 1/2 equals 1/2. So when the angles are congruent and the sides are proportional, then we can say for sure, yes, these two triangles are similar. So that was a quick review before we get into today's notes, okay? And those are really important principles to know. And you really, I don't want to depress you or frustrate you if you're behind on that, but you really should know that pretty well, okay? All right, let's go ahead and start taking some notes now. We're going to look at the following information. Would you please grab your notebook and copy this heading in your notes? Copy this down, please. We are looking today at segments in the interior of a triangle. The lesson number is 7.5, and the date today is the 27th, okay? The 27th. So segments in the interior of a triangle. And while you're copying that down, I'm going to add another sentence right here. You do not need to write this sentence unless you want to. That's up to you. But today we're going to be looking at 3 different theorems dealing with a segment that is inside of a triangle. Okay, so that's what we're going to do today. We're going to look at 3 different theorems. And so you can write that down if you want to. You don't have to, but definitely write down the heading. All right. And with that in mind, let's go ahead and look at these 3 different theorems. Here's one of them. Here's the other one. Here's the other one. And then we're going to go ahead and look at some problems that will help us apply those theorems. Okay, so once again, I'm kind of rambling, so you have time to copy this down. We're looking at segments in the interior of a triangle, lesson 7.5. Today's the 27th, and we're looking at 3 theorems today. All right, here's the first theorem we're going to look at. Please copy this into your notes. Theorem 7.4. It's called the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Okay, I'm going to pause for a minute. Don't pause the video. I'm just going to get quiet for a second, give you a minute to copy that down, and then I'm going to give you a picture of what this means to help you better understand this. Okay, you're probably still writing, but I can still talk a little bit while you're writing. I want to give you a picture of what this is saying, okay? So I'm going to give you a triangle here. There we go. And I'm going to go ahead and draw a line right here. And I would like you to do this too, okay? This is very important for you. And we're going to call this, let's get some different colors there so it's easier to see. Please put this in your notes. We're going to call this A. Call that B, C, D, and E, okay? Now here's what this theorem is saying. Please watch carefully, and I think this will make sense. If you're given a triangle, and obviously we have a triangle, and inside that triangle right here, you have a segment. Everybody see that segment? Segment BD. Go ahead and put a parallel symbol. If that segment is parallel to one of the sides of the triangle, then here's what we know for sure. Are you ready? Please watch this carefully. We know that this segment right here, BC, can be put over this segment right here, AB. So I can write CB over AB. equals, and then I can put this segment here, which is CD, over this segment here, which is DE. Okay, so let's go over that again. This theorem is saying when you have a triangle, and we have a triangle, and on the inside of that triangle we have a segment that's drawn like this, and that segment is parallel to one of the sides of the triangle, then that parallel line, this parallel line right here, divides these sides right here up into proportional sides. So I can put CB over AB, and that will equal this segment CD over DE. That is what this theorem is teaching. Okay? Let that sink in for a second. Not easy, but it's important. We're going to come back to this in a minute and review this, okay? Now, if anytime you need to pause the video, you know by now to feel free to do that, okay? All right, going on to Theorem 7.5. Now, I'm going to read this, and then do not pause the video. I'm going to give you time to write this down. Theorem 7.5 states, if a line. Let me back up. Theorem 7.5 is the opposite of this last theorem, okay? Over here, we said if a line was parallel, then it divides these sides up proportionally. Now, this theorem says if a line divides the sides up proportionally, then it's parallel. So it's kind of the opposite of the other theorem. But here's what it says. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. And we know that for sure. Okay, so I'm going to get quiet, copy this down, then I want to give you a picture of what this is saying. Okay, if you're still writing, that is fine. I want you to go ahead and draw this triangle in your notes. And then I want us to go ahead and put a line right here. All right? And then we're going to label our triangle X, Y, Z. You know what? I'm going to use numbers instead. So I apologize. Break out your erasers. Thank you. I'm going to call this a length of 3 and this a length of 6. I'm going to call this over here a length of 4 and this right here a length of 8. All right? Now that's all you're given. Here's what this theorem says. This theorem says this. Are you ready? It says if you have a triangle, and we do have a triangle, and you have a segment drawn inside the triangle, which we have that segment right there. I'm highlighting it in red right now. If this segment right here divides these two sides up proportionally, then I can state that these two lines are parallel. Well, let's see if we have proportionality here. I have a 3, and I can put that over my 6. So 3 over 6 equals, and here's my 4. Let's put it over the 8. And let's see if we can reduce these and get the exact same fractions. 3 over 6 reduces to 1/2, and 4 over 8 reduces to 1/2. So yes, these sides here are proportional to these sides here. So I can definitely state that this segment here is parallel to this segment here. Now, do you see what we did there? Let's go back a page. Back here, you were told you have parallel lines. So since you knew you had parallel lines, then you could write proportionality statements. Here, we're saying, okay, I can write proportionality statements, thus I know that these two lines here are parallel. So they're the opposite, or the exact geometry word to use is these two theorems are the converses of each other. Okay, and that's what that means. Okay, let's continue on to another theorem, and then we'll get into a bunch of math today, over and over and over, until you're probably about ready to pull your hair out. All right, here we go. Theorem 7.6, the mid-segment theorem. The segment connecting the midpoints of the two sides of a triangle. Let me say that again. You have a segment that is connecting the midpoints of the two sides of a triangle. When that happens, that segment is parallel and it's half as long as the third side. So it's parallel to the third side and half as long as the third side. I'm going to get quiet and let you copy this down. Okay, hopefully that's long enough. Let me show you exactly what this theorem is stating, okay? Please copy this in your notes. Here's your triangle. And now I want you to kind of guess where the midpoint of this segment is right here, or that side of the triangle. It looks like the midpoint would be about right there. I think that's in the middle. And now we're going to come over here and find the midpoint. It looks like it's about right there. There we go. So go ahead and connect those 2 points, all right, like I've done there. Now, here's what this theorem is saying. If this segment is connecting the midpoints of this side and the midpoints of this side, then I know for sure that this line right here is parallel to this line, and it's also half the length of this side here. So what I want you to do in your notes is I want you to put 1 mark here and 1 mark here. Hey, isn't that true? Think about it. If this is the midpoint of this side right here, if that's the midpoint right there, then that means that point right here divides this up into 2 equal segments. And I can come over here and put 2 marks here and 2 marks here. Isn't that true? Because if this is truly the midpoint, which it's supposed to be, then that means it divides this segment up into 2 equal segments. So if I know that this segment's congruent to this segment, and if I know that this segment's congruent to this segment, then what does this theorem tell me that I know for sure? Well, I'm glad you asked. You know that this length here, we'll call it 3, will always be half of this length down here. So what would this length be? 6, correct? And we also know that this line here will be parallel to this line here. Now again, those 2 things that I just said are only true when this is the midpoint of this side and this is the midpoint of this side, and that segment connects them. Okay? Now if that's true, then we know that these 2 lines are parallel and this smaller segment here is always half whatever this is down here. Okay? Alright, let's quickly review and we'll get into some problems. Okay, the first thing we learned is this. If a line is parallel, a segment is parallel to one side of the triangle, then we know that CB can go over BA and CD can go over DE like this, and they're equal. And then we learned if you have a segment drawn inside of a triangle in such a way that this over this equals this over this, if that's true, then we know for sure that this line is parallel to this line. And then lastly, we learned that if I have a point right here that's on the middle of that line, and if I have a point here that's on the middle of that line, and I have a segment that connects those 2 points, then I know 2 things. This line is parallel to this line, and this segment is always half as long as this one. Or you can say this segment here is always twice as big as this segment. Okay, let's move on. Anytime you need to pause the video, feel free to. We're now going to do quite a few problems, it looks like. couple hundred. So let's get ready to look at those. Quite a few, actually. Copy that in your notes, please. I'm going to get quiet while you copy this in your notes. Okay, I do need you to write very quickly today so we can get a lot of math covered, so I'm going to continue on. Here we go. Do you see how I'm telling you DE, right here, is parallel to BA? Do you see that? That was given to you. Parallel symbol here, parallel symbol here. So the first theorem we learned today said if this segment inside the triangle is parallel to a side in the triangle, then we know that we can write proportions. So that's how we're going to solve for x. Remember what I taught you? You can take this segment here, which is 4, and you can put it over this segment here, which is 8. And that would be equal, and then you put x over 12. Let's go ahead and cross multiply. 8 times x is 8x. 4 times 12 is 48. And now we divide both sides by 8, and x equals 6. That's really pretty simple. Now I knew I could do that because what? This side here, or this segment here, was parallel to this segment here. Okay? All right, I want you to try one for a bonus point. So I'm going to go ahead and put this up. I'm going to pause the video, and I want you to restart it once everybody's done. This is for a bonus point. Okay, here we go. Notice this segment right here, LN, is parallel to this side, KP. And when that's true, you can then put x over 22 equals 10 over 20. Now let me stop and say this. You might have put 22 over x equals 20 over 10. That's totally fine. Either one of those two will work. Okay, 20 times x is 20x. 22 times 10 is 220. Divide both sides by 20, and x will equal 11. Okay? Now, again, you pause the video whenever you want to. I move on, and I trust you guys to help each other, ask each other questions, rewind the video, whatever you got to do. Okay? All right, moving on. Do not pause. Let me go put the new problem up here. Okay, I'm gonna let the video run, so don't pause it. Go ahead, and I'm gonna give you about 30 seconds to copy this down. So don't go for neatness, go for speed. Okay, quickly copy this down. And this is a little different, so you might not want to work ahead. So copy this down while I'm rambling. This is gonna be, you know, a little more interesting. Take a second and copy this down. Okay, hopefully you've copied this down. Now this is really interesting because notice I have a segment here or a side here parallel to a side here. Okay, so right away you should realize you can put 3 over 9 and you can put y over, oh, well that's a problem. There's nothing here. And so that's you know, interesting problem here. So let's think about this for a second, okay? Let's just kind of think all this through. I do have this side here, okay? And I have the whole length of this over here. So I have an idea how I could use proportions here. I've never really taught you this, but it all makes sense. Instead of putting 3 over 9, why don't I put 3 over the whole side, which is 12? Now I can do that, students. I can do that as long as I do the same thing down here too. So instead of putting 3 over 9, I'm going to put 3 over 12. All right? Equals, now, instead of putting y over this segment here, I'm going to put, just like I put 3 over the whole length, I'm going to put y over the whole length. And I know that whole length is 20. And you can also do that. So now you've learned something new. You know you can put this side over this side equals this side over this side, but you're also allowed to put one of these segments over the total as long as you put the corresponding segment over the total also. Well, let's go ahead and cross multiply. 12 times y is 12y. 3 times 20 is 60. Divide both sides by 12 and y equals 5. Y equals 5. Okay? All right, moving on. Again, if you got to pause the video, feel free to do that. All right, I'd like you to copy this problem in your notes. Do not pause the video. I'm going to go ahead and give you a second to copy that in your notes. And students, while you're copying this down, my son has asked me a question, so I'm going to talk to him. So go ahead and copy this down, okay? You get about 15 minutes, okay? Because you had 20, I had it all up already for you. And so you played 5 already, so you have 15 minutes. Well, I'm on a video now, okay? So you go ahead, and that's what you get, and we'll discuss it later, okay? Thank you. All right, hopefully you have time to copy this down. We're going on to that second theorem now. Remember I told you if these two sides here, or these two segments, are proportional to these two over here, then we know for sure that this segment here is parallel to that segment there. And you're probably like, no, I don't remember that at all. So let me flash back real quick. It was this theorem right here in your notes, Theorem 7.5. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. Okay? So let's go ahead and let's take a glance. Did I go too far? Let's take a glance at this problem. So let's see if we have proportionality here. Remember, I can put 56 over 21. So I'm going to say 56 over 21 equals, and then I can put 48 over 16. So here we go. 48 over 16. Well, let's see what happens here. Let's reduce. I know 7 goes into both of these, and 7 would go into 56 8 times. It would go into 21 3 times. And then we come over here, and we're going to reduce this by 4. Actually, you would get 3 over 1. Okay? So did we get out 2 equal fractions? No, we did not. So can we say that this segment here is parallel to this side here? The answer is no, we cannot. No, okay? These lines here, MN and GH, are not parallel. Okay, I'm going to move on. Pause the video if you need to. I would like you to try this one for a bonus point, okay? I am going to go ahead and pause the video. Actually, I'm not going to. So you go ahead and you pause the video. And as soon as everybody's done working it out, then turn it back on, okay? So go ahead and work this out for a bonus point. Okay, you should have turned the video back on. Let's see how you did. Well, we can put 21 over 15. Now, by the way, if you put 15 over 21, that's fine, as long as you put 17 over 23. I'm going to put 21 over 15. Okay, equals, and then 23 over 17. Well, obviously, you're not going to get out 2 equal fractions. First of all, 23 over 17 cannot be reduced, and this over here can be reduced by 3 to 7/5. So no, the 2 fractions are not equal. So are segments RQ and TS parallel? No, they are not. Okay, hopefully you're getting these right for some bonus points. Okay, I want you to go ahead and copy this in your notes. Do not pause the video. I'm going to let it run while I'm just going to sit here and be quiet. So go ahead and copy this down quickly, and then we're going to move on. Copy this quickly, please. BE and CD, are they parallel? Okay, well here's what you've been taught. You can put this segment over this segment, 15 over 6 equals, and this segment over, oh wait, I don't know that one. Well, that's okay. Do you see this, students? What's the whole length of AC? Isn't it 4? So if that much is 10, then this has to be what right here? Doesn't that have to be a 4? 10 plus 4 is 14? Sure it does. So 15 over 6 equals 10 over 4. All right, let's reduce. Here we would get 5 halves, and here we would get 5 halves. So yes, we finally have some sides that are proportional. So yes, we can say that BE is parallel to CD. All right, okay, moving on to some more problems here for your pleasure and enjoyment. 3 left to give you a little closure. 3 left. Do not pause the video, let it run, just copy this down, and I'll be quiet here for a second. What is the length of QS? What is the length of QS? Copy this down quickly, and be sure to include all of these little tick marks. They are very, very important. Okay, here we go. Students, what you've learned is when this segment right here is congruent to this segment down here like we have, then you know this point here is called the midpoint. It's right in the middle. And whenever you see that RS right here is congruent to ST, then it's common sense. This is the midpoint right here. So what we have is a triangle, and in that triangle we have a segment that's connecting the midpoints. Whenever that happens, first of all, we know that this segment here is parallel to this segment here. So go ahead and write that down. And then what is the length of QS? Well, remember, this segment here is always going to be half of this right here. Or you can say it backwards. This segment here, PT, will be twice as big as QS. So if PT is 10, then what's the length of QS? Well, half of that. The answer is 5. These are pretty easy. These really are easy here. Okay. All right. Let me glance at my notes here. Let's go on to this one right here. Let's find the value of P. Now I think you know the answer right away is probably 8. But I want you to quickly take a second and copy this down. Would you please do that? Take a second and copy this down. Try to go quickly if you can because we're running out of time. And I don't mind taking the whole class period. I'm not teaching tomorrow. And there's no homework tonight. But notice that this segment right here I'm highlighting in green. This segment right here is congruent to this segment right here in blue. So if that's true, then I know this point here must be in the middle. Okay? And then look over here. I have this segment here is congruent to this segment here. And so if that's the case, then I know this has to be a midpoint. So I've got a triangle, and on the inside of that triangle I have a segment that's connecting the midpoints. So I know first of all that this segment here is parallel to this segment here. And then if this is 16 right here, what would this length up here have to be? Well, P would have to be 8. Half of 16. And now let's do one more and we're finally done for the whole day. So no cheering allowed. All right, copy this whole thing down. Do not pause the video. I'm going to wait while you copy this down. So please copy this whole problem in your notes. I'll give you just a second to do that. Please copy it quickly. And then we're going to find the perimeter of triangle ABC. Excuse me. Okay, I'm going to start rambling while you're finishing this up. I know I'm being amazingly redundant, but I would rather be boring and not lose you. So notice that this segment right here in red is congruent to this segment right here in green. So if that's the case, then I know this is a midpoint right here. And then I notice that this segment right here in green is congruent to this segment right here in blue. So if that's the case, then I know this point right here is a midpoint. So what I have is a triangle, And on the inside of that triangle, I have a segment that's connecting the midpoints. So I know, first of all, this line here is parallel to this line here. And now we got to find the perimeter. Well, that shouldn't be too hard. We know from here to here is 4, and I know these segments are congruent, so from here to here it has to be 4. And in case you've forgotten what perimeter means add up the sides, the length around the figure. All right. Now notice from here to here is 3, and if that's the case, then this segment here has to be 3 also. They're congruent. And then if this is 5, you've learned that this segment inside the triangle is always half this segment down here. So if this is 5 right here, then this segment right here must be 10. So I have 3 plus 3 plus 10 plus 4 plus 4, and that would be 24. So the perimeter of ABC is 24. All right. Now, I'm not going to give you the homework assignment. I want it to be for tomorrow's class. Reason being is it's not that long, so I want it to last during the class period. I will have a video ready for you tomorrow to listen to in class if it helps you with your homework. We will also go over the quiz tomorrow, so you're ready for the quiz on Friday. Okay? Hope you guys have a great rest of the day. Please keep working hard. Do your homework every night. I know you don't have homework tonight, but do your homework every night that you have homework, and do not get behind. All right? Email or call if you have questions.